Time to chat about that TCPIP networking model, and also I'm going to share some real-world tips with you here. I've been teasing a little bit, and we're going to use these models not only to succeed on the exam, but also to succeed in troubleshooting real-world networks. And you're going to see how. But let's talk about this particular networking model for just a few minutes. This model originally had 4 layers. And what a pain it was, because especially for CCNA candidates, because the bottom layer had 3 different names. Then the networking layer, or the internetwork layer, or the internetworking layer, whatever you want to call it, that had a couple of different names. And the name you saw depended on the book you were reading, because that's actually that model was still in use when I wrote my first book and created my first course. And I would use one name for the layer, and the people say, no, it's called this. I'm like, well, I'm looking at it. We were all looking at the right thing because it just had so many different names, each of the layers. Now, thankfully, this model has not only evolved into a 5-layer model, but this bottom layer that I'm talking about is now known by one simple name, and it matches the OSI layer exactly. Now, if you are familiar or you are seeing other versions of the TCPIP model, this is the most recent one. This is the one you want to know for the exam. Because if you go out right now and you Google TCPIP model and you go over to the images section, I'm not going to do it here because of copyright issues. I don't want to show anybody's copyrighted work. But if you go in there, you'll see, you'll see 4-layer model, you'll see 5-layer models, you'll see some of the layers called different things. It's just crazy. Well, you can see why we like this one so much, because the only real difference between the two is that the application layer of the TCPIP model maps exactly to the top 3 layers of the OSI model. Application, presentation, session. It does exactly what those 3 layers do. And then after that, it's an exact one-on-one mapping, and they even use the same names. Transport layer on the TCPIP model does the exact same thing as the OSI model, and so forth. So you're looking at those models and you hear what I'm saying, and you got 2 natural questions at this point, which closely mirror the questions I had at this point in my studies. First off, why do I need network models in the first place? Does anyone really care? Am I really going to use these? You are, and we're going to talk about that in a moment. But the other question, especially for those of you new to the models, why do we have 2 major network models, especially since they're so very similar? Now, they weren't similar originally, but they sure are now. I mean, they're pretty similar. So why do we still have 2 of these around? Well, let's talk about the first question first. Why do we use network models? This part doesn't mean as much to you and I as it does to developers, but with these models, we have standards. And when we utilize a given set of standards to create something, you don't have to worry so much that it's not going to work with another program or on a certain computer. It allows you to create products and programs that play well together, and apps as well. And you and I are all for that, because that's one less thing that we have to troubleshoot. That other benefit, though, the major benefit, is of particular interest to you and I as CCNA candidates and as network admins. It's going to make both of our jobs easier. Now, network models were not developed in order to aggravate us on exam day. It might seem that way at times. It certainly seemed that way with the original TCPIP model. But you can use these models as a map to success on your exam, especially those bottom 3 layers. Because let's face it, we're throwing a lot of stuff at you for the CCNA certification. I mean, there are a lot of topics. And without a structured study plan, it's really easy to get lost. And it's a lot easier to succeed with this simple 3-part plan. And fortunately, most books, if not every book, is going to be designed like this, where you learn about the physical layer first, then you go to the data link layer, and then you go to the network layer. My books are laid out the same way. One tip I want to give you here, though, for your studies. The number 1 mistake I see CCNA candidates make when they get started is that they're rushing. Because, and again, just being brutally honest here, the physical layer information is probably the least interesting info, because you're not doing as many labs. You're not doing a lot of work on switches. You're not doing a lot of work on routers. You got to learn some cables. You got to learn some cable types. You got to learn some Ethernet standards. Not the most exciting stuff in the world, but it is important stuff. We got to know it, and you can't rush through it. Just make sure you're comfortable with L1 before you move to L2. Then, of course, make sure you're comfortable with layer 2 before you move up to layer 3. In routing, because all we're doing here is taking a huge task and we are breaking it down into small, more manageable jobs. Section by section, layer by layer, we're going to become a CCNA. Now, you can also use these models for success in the real world, especially when it comes to troubleshooting. Because for most network admins, troubleshooting is all they do. You know, we get to install a little bit of stuff, sure, but we don't configure all our routers and switches from scratch every single day, you know, which is actually a good thing. We do a lot of troubleshooting. And, you know, there are really two kinds of network admins. I've said this for a long time and I'm standing by it. Those who have a structured plan for troubleshooting and those who don't. And I don't mean some huge flow chart with 80 boxes and 60 arrows, okay? I mean a very simple 3-step process. First off, whether you're troubleshooting in person, whether you're doing it over the phone, whether you're doing it with some kind of remote desktop, always troubleshoot the physical layer first. Always. If the device in question isn't on, it ain't going to work. And some of you are laughing to that, and some of you who have had desktop support jobs or phone support jobs like I have, sometimes that took a few minutes with a customer. You know, well, I'm trying to do such as, well, let's make sure it's on first. And people get frustrated with that. But you've got to start at point A and then work your way up, or layer 1, if you will. Because if everything's fine physically in your network issue, fine, wonderful. Start climbing the OSI model. Troubleshoot layer 2. If everything's good there, even better. Time to troubleshoot layer 3. But don't just sit down and start doing show config and just looking around and not really having a plan as to what you're doing. Go layer 1, layer 2, layer 3, and you'll be amazed at how many layer 1 issues can be, how many issues actually are layer 1. Now, why do we have 2 of these? Well, the OSI model is not the main model in use by today's developers. But what we've done, we keep using the layer names and the numbers because the TCPIP model layer naming was crazy originally. I'm actually going to show it to you in a moment, and you'll see what I'm talking about. Now, the OSI model itself, a quick history lesson here and a brief one. The OSI model is actually the result of a merger of 2 other sets of international networking standards. So see, it could be worse. We could have 3 networking models. One of those 2 was developed by the International Organization for Standardization. I love that name. It's as generic as it gets while sounding all-powerful. The International Organization for Standardization. Okay, that's the ISO. And the other by the International Telegraph and Telephone Consultative Committee, CCITT. And yes, I know these initials do not match up. I believe CCITT actually came from another translate, or the French translation, yes. Because I used to look at ITTCC when I was studying this, and it's like, and then it's CCITT? How does that work? So, meanwhile, the DoD right here in the United States of America, the Department of Defense, was developing its own networking model, and that was the TCPIP model. And yada, yada, yada. In a nutshell, TCPIP took over the networking world, and naturally, that model became the standard networking model over time. So if that's true, that's great, you say, but why does everyone still use the OSI model, especially when we're talking about troubleshooting, you know, L5 issues and L6 issues, that kind of thing? Well, basically, it's because we started doing so a long time ago, because the OSI layer names have been the same for a long, long time. And the TCPIP model layers, as I've mentioned a couple times, used to have very different names, not to mention multiple names. And here's what I'm talking about. This is the original TCPIP model with a little editorial comment from me because it's my class. And the maybe is my commentary, okay? It wasn't called the link maybe layer, although, you know, second thought, that's actually a pretty good name for a layer. Maybe it's going to link, maybe it's not. But what I mean there is that maybe it was called the link layer, maybe it was called the network access layer, maybe it was called, was it network interface layer? Oh, it's just crazy. And the internetwork layer, and I still call it that because officially it was the internet layer. I also saw it called the internetwork layer, the internetworking layer, just the network layer, and then a couple of, I think another name. And you can see where the lack of standardization of names to the bottom 2 would cause you a bit of angst as an exam candidate, exam student, because you're studying 3 different books, and the 3 books called the bottom layer of the model, each a different thing. It drove you a little bit crazy. So thankfully this model is no longer in use, but that's what we used to have to put up with. And you know, you could tell another admin that you had a network access layer issue back then, and she would just hear network and say, oh, okay, layer 3, a routing issue. Well, not necessarily. It was not a common term because people have stuck with the OSI terms. And that's really, it's not the only reason the OSI model is still around, but it's a major one. And thankfully, as we saw earlier, the TCPIP model now uses the same names as the OSI layer, with that only real difference being the top. And let's just take one more look at that again. And there you go. There's your mapping. It's much easier than it used to be, but you should still be familiar with that, especially the top of the TCPIP model and which layers map to the OSI layer. So let me go back through these. And here's a little something for you using the OSI model. This is a very partial list of protocols. You may be familiar with all of these. If not, we will take care of that during the course. But I just want to show you at which layer of the OSI models in particular these are going to run. And like I said, we're going to spend plenty of time, especially with the bottom 3 transport layer. I've got a special section on that for you. But coming up next, we are going to talk about Ethernet and the physical layer, and that is coming up next.